everyone and welcome to Pentagon. Today I have a geometry problem for you all. We have right triangle ABC such that angle A is 54 degrees, angle C is 36 degrees, and the length of AC is 20. This right triangle is now inscribed in a circle, and we need to find the difference of the areas of the green region and the blue region. This is a fun little challenge, and I encourage you all to pause the video here if you'd like to try and solve it yourself. Alright, now the first thing we want to do is make use of this helpful little theorem here, which I'll pull up. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. I won't be proving this theorem in this video, but please leave a comment below if you'd like me to do so in a future video. Very well. Now, we can apply this theorem to our little problem here. We know that ABC is indeed a right triangle, and it is inscribed in a circle. Therefore, the hypotenuse, which in this case is AC of length 20, must be the diameter of our circle. This also means that the center of our circle lies on AC and is, well, in fact, the midpoint of AC. So let us draw that in, hopefully accurately. So let's put the center right there and let's call it O. Alright, now we know that the radius of a circle is half the length of the diameter of the circle. And we can say that OA and OC are radii, so they must be 1/2 of 20. So OA and OC are both 10. Alright, now let us draw segment OB. Alright, that's good enough. Now we can say that OB is also a radius, so this will also be of length 10. Alright. Next, we'll start finding some angles. Let's look at triangle OAB. We can say that this is an isosceles triangle because we have two sides of this triangle, specifically OA and OB, that are congruent. They're both of length 10. From this, we can conclude that the base angles of this triangle are also congruent. Therefore, if angle OAB is 54, then the measure of angle OBA must also be 54. And we can do the same to triangle OBC, since this is also isosceles. Since the angle OCB is 36 degrees, then the measure of angle OBC must also be 36 degrees. Right. Now let's try to find angles AOB and COB. How can we do that? Well, we know that the sum of the angles in a triangle is 180 degrees. So if we take triangle OAB, we can say that 54 plus 54 plus the measure of angle AOB equals 180 degrees. When we simplify this, we get 108 plus the measure of angle AOB equals 180 degrees. And when we subtract 108 from both sides, we get that the measure of angle AOB is 72 degrees. Wonderful. Now, we know that AOB, angles AOB and COB are supplementary, meaning they add up to 180 degrees, which is the measure of a straight line. Using this, we can say that the measure of angle AOB, which is 72, plus the measure of angle COB, equals 180 degrees. When we subtract 72 from both sides, we get that the measure of angle COB equals 108 degrees. All right. Now let's try to find the areas of the shaded regions. How will we do that? Well, it'll be as follows. The area of the green region is equal to, or can be expressed as, the area of sector OBC, which is this large pizza slice, if you will, minus the area of triangle OBC. And likewise, the area of the blue region is equal to the area of sector OAB, this smaller pizza slice here, minus the area of triangle OAB. All right. Now, how do we find the areas of the sectors? We know that the area of a circle is equal to pi times the radius squared. So if we take sector OBC, this is a small chunk of the circle's area. So we need to multiply this by a fraction. Well, what fraction? If we take the area of the full circle, pi times the radius squared, and we know that in a full circle there are 360 degrees in total. But in this sector we are only taking 108 of the 360 degrees. So we need to multiply the area by 108 over 360. Now we know that the radius is 10, so if we substitute that in, pi r squared is pi times 10 squared, which is 100 pi, times 108 over 360, which simplifies to 30 pi. All right. Now let's do the same for sector OAB. Once again, the formula for the area of a full circle is pi times the radius squared. And out of the total 360 degrees, we are taking only 72. So for this sector, we need to multiply by 72 over 360. And the radius is 10. So this becomes pi times 10 squared, which is 100 pi. Times 72 over 360, which simplifies to 20 pi. Wonderful. We now have the areas of the sectors. We just need to find the areas of the triangles. Or do we? In fact, I don't have to find the areas of the triangles because I know for a fact that triangles AOB and COB have the exact same area. I can prove this by drawing the altitude of each triangle. That's one altitude. and there's the other. Alright, so now if you can see, we now have 4 smaller, exactly congruent right triangles. Each of these smaller right triangles has dimensions of 1/2 the base and 1/2 the height. And both triangles OAB and OBC are composed of exactly 2 of these smaller right triangles. Therefore, they have the exact same area. So instead of solving numerically for the areas of these triangles, let us simply denote the area as y, the letter y. Alright. Now, let's go back to our original formulas. We said that the area of the green region is equal to the area of sector OBC, which we solved for was 30 pi, minus the area of triangle OBC, which we said was y, and the area of the blue region is equal to the area of sector OAB, which we said was 20 pi, minus the area of triangle OAB, which we denoted with y. And the question is, what is the difference of these areas? Well, let's compute that. The green region minus the blue region is going to be equal to 30 pi minus y minus, in brackets, 20 pi minus y. If we distribute this negative and remove the brackets, we get that this equals 30 pi minus y minus 20 pi minus y, plus y, rather. And now you see why simply denoting the areas of the triangles with y was so helpful. In this equation, the y's simply cancel out, and we are left with 30 pi minus 20 pi, and our final answer is 10 pi. Thank you for watching this video. If you liked it, please consider subscribing to this channel. Thank you all, and I will see you in the next video.